Now let us talk about thermodynamic equilibrium. Mainly there are four types of equilibrium possible in a thermodynamic system. One is stable equilibrium. Next one is unstable equilibrium. Then there is a metastable state, that is not the lowest energy state, but it is also stable for some extent. And then there is a neutral equilibrium state. And it is very easily explainable using the diagram in this slide. In stable equilibrium, whatever be the condition, that ball tries to be in that state itself because it is the most stable state. While in unstable state, the ball can either go to right or left. In metastable state, even though it is in an equilibrium state, there is also an availability of a lower energy state than the original one. So such a state is called metastable state. In neutral equilibrium, whatever position it occupies forever. And that situation is called neutral equilibrium. The stable equilibrium position is actually called as thermodynamic equilibrium. The system tries to remain in the same state, whatever the conditions in the surrounding changes. So I can define thermodynamic equilibrium as even if a small external force is applied to the system and released, the system would come back to the thermodynamic state where it was originally. For that is, the value of all extensive and intensive variables would recover. Now let us discuss some of the important processes in thermodynamic system. One is isothermal process. In this process, temperature remains constant, but pressure and volume can change because in this process, the system can absorb energy from the surrounding. And it is very beautifully represented in the figure. Another process is adiabatic process. In this process, the system is isolated from the surrounding. It's very clear in the diagram that there is an insulator between the system and the surrounding. Hence, exchange of energy is not possible. Now, what is happening? The volume is increasing and system is attaining stability. So, the temperature decreases as volume increases. And such a process is possible in an adiabatic process where there is an instantaneous expansion and a lowering of temperature. And it is actually used in Jacquet effect, Joule-Thomson effect, which we will learn in a later stage. Now, comparing the processes, it is quite clear that graph number 1 represents the isothermal process and graph number 2 or the slope curve number 2 represents adiabatic process. Since in adiabatic process there is a drastic change in volume with respect to pressure. While in isothermal process, even though there is a change in volume with respect to pressure, it is not as drastic as that of adiabatic process. Now another process is isochoric process. In this process, the volume is fixed. So what happens? As temperature increases due to application of heat from the surrounding to the system, the pressure increases. Now another process is isobaric process where the pressure inside is kept constant. As we apply heat to the system, the volume increases as well as temperature increases. Such a process is called isobaric process.